Hello dear fans. How to determine the projection of a vector. A vector can be thought of as an ordered pair of points in space or a directed segment. In the school course of analytical geometry, various tasks are often considered to determine its projections on the coordinate axes, on a straight line, on a plane or on another vector. Usually we are talking about 2- and 3-dimensional rectangular coordinate systems and perpendicular vector projections. Instructions. Step 1. If the vector A is specified by the coordinates of the initial A, x, y, z, and final B, x2, y2, z2, points, and you need to find its projection, P, on the axis of a rectangular coordinate system, it is very easy to do this. Calculate the difference between the corresponding coordinates of 2 points, i.e., the projection of the vector AB on the abscissa axis will be equal to px equals x2x, on the ordinate axis py equals y2y, the applicate pz equals z2z. Step 2. For a vector specified by a pair or triple, depending on the dimension of the space, of its coordinates A, x, y, or A, x, y, z, simplify the formulas of the previous step. In this case, its projections onto the coordinate axes, x, I, az, are equal to the corresponding coordinates, x equals x, I equals y, and az equals z. Step 3. If in the conditions of the problem the coordinates of the directed segment are not indicated, but its length is given, A, and direction cosines cos x, cos y, cos z, you can define projections on the coordinate axes, x, I, az, as in an ordinary right-angled triangle. Just multiply the length by the corresponding cosine, x equals A, asterisk cos x, I equals A, asterisk cos y, and az equals A, asterisk cos z. Step 4. By analogy with the previous step, the projection of the vector A, x, y, onto another vector A, x2, y2, can be considered as its projection onto an arbitrary axis parallel to the vector A and having the direction coinciding with it. To calculate this value, A, multiply the modulus of the vector A by the cosine of the angle, alpha, between the directed segments A and A equals A, asterisk cos alpha. Step 5. If the angle between the vectors A, x, y, and A, x2, y2, is unknown, to calculate the projection, A on A, divide their dot product by the modulus A equals A asterisk A slash A. Step 6. The orthogonal projection of the vector AB onto the line L is the segment of this line formed by the perpendicular projections of the starting and ending points of the original vector. To determine the coordinates of the projection points, use the formula describing the straight line, in general A asterisk x plus b asterisk y plus c equals 0, and the coordinates of the initial A, x, y, and end b, x2, y2, points of the vector. Step 7. In a similar way, find the orthogonal projection of the vector A onto the plane given by the equation. This should be a directed segment between 2 points of the plane. Calculate the coordinates of its starting point from the plane formula and the coordinates of the starting point of the original vector. The same applies to the end point of the projection. Thanks for watching.